It's about, okay, so power your DC. DC stands for data center. So it's mostly for people who run their own data center. We currently have a full set of open source software you can run. There's not much real own, open source hardware. So I believe the bring your own device is a wrong abbreviation, and it's build your own data center. Whether it's a big one or a small one, it doesn't make a difference. You want some type of cloud concept in that. So we have open source. We have now also some open source hardware, mostly relating in ARM or in Power. And this presentation will talk about the Power. So most people know Power from IBM. Now there's the OpenPOWER Foundation, which actually are machines which run fully open source software and fully open source hardware. The open copy is because it's a RISC processor, so it has a reduced instruction set and uses coprocessors to do other work. So the first platform that was fully open source is the Power 8. You can actually buy machines which you can compile your own firmware, your own bootloaders. Yeah, for people who are a little bit longer and more acquainted with the kernel, there's a difference between little endian and big endian. Typically, Unix-based platforms were big endian. Linux is little endian. So, well, Linux can do both. The Power became little endian so that it is more compatible with Intel-based systems. Threading, it has about 8 threads per core. So a system can go up to 192 threads or more. The open firmware is fully open source on GitHub. So you can actually download it, compile it, run it in an emulator. If you like it, put it on a physical machine. The bootloader uses SkiBoot, which is the actual BIOS type, and the Petit boot is basically just a nice TUI which tells you which kernel you want to boot up. The machines are made by, the OpenBMC is your out-of-band connectivity, so your IPMI based system. Again, there you can compile it yourself. If you want to have your own tool sets in there, if you want to have a nicer web-based interface, if you want to be able to do stuff on SSH, you can do that. Typically, they come in 2 types of machines, scale out and scale up. That's not that interesting for most people, most probably. But you can have up to 4 sockets. These are some of the manufacturers that are currently providing it. Except Google, I presume you can buy the other ones online. Google builds them themselves for their own data center. They don't sell the machines, actually. And relatively speaking, you have a lot of distributions which are already available there. The ones in bold are the ones that are most supported. And you have FreeBSD even if you are a Unix person. Most of the open source software can be run on it. So by default, it runs a KVM-based QEMU. Docker also works there if you're a Docker person. OpenStack has it. OpenNebula is a different type. I ran a test and I was able to run about 1,000 VMs on one physical machine. Porting software is quite easy. Just recompile it, given that you have the source. You have all the tool chains, you can just compile it again. And these are some of the other applications that are most commonly used and have been tested by other vendors already. There are also certain databases which actually can go very high in scalability. Yeah, so IBM and MariaDB did a test and they got up to 1 billion transactions per second. If that's what you need, that high number of transactions per second, this can be an option. Yeah, most of the languages are supported. Like I said, it's all open source based. So if you can run it on one platform, you can run it on this platform. There should be more slides? No. Yeah. I'm quicker than the slides, apparently.